Hello, and welcome back to the channel. Today, we're going to demystify a core component of global internet performance, CDNs demystified, how Cloudflare and Akamai supercharge global speed. At its heart, a content delivery network, CDN, is a highly distributed network of servers strategically placed around the globe. Its primary purpose is to efficiently deliver web content, whether it's static files like images, CSS, and JavaScript, or dynamic content and videos from locations geographically closer to the end users. The core benefits of a CDN are profound. It dramatically reduces latency, the time it takes for data to travel, significantly improves load times for web pages and applications, and actively decreases the bandwidth usage on your origin servers. By caching frequently accessed static content at these distributed edge locations, the CDN minimizes the physical distance data must travel between the server and the user. This is an absolutely critical infrastructure component for any global application, from streaming giants like YouTube and social media platforms like Instagram to large-scale e-commerce sites. Let's walk through the fundamental process of how a CDN operates when a user requests content. User requests a resource. When a user initiates a request for content, for example, trying to watch a video or view an image on a website, their request is typically directed to the CDN. Request hits the nearest edge server. Instead of going all the way back to your main origin server, where your website is hosted, the request is intelligently routed to the nearest edge server within the CDN's vast network. An edge server is a data center owned by the CDN provider, located close to the user. If cached instant response, the edge server first checks if it already has a cached copy of the requested video or image. If it does, cache hit. It immediately delivers the content directly from its local storage to the user. This delivery happens with minimal latency. If not, fetch from origin, store locally. If the edge server does not have the content in its cache miss, it then fetches the content from your central origin server. Once it receives the content, it serves it to the user and stores a local copy in its cache. Next request is lightning fast for all subsequent requests for that same content from users near that edge server. The content is served directly from the edge cache, resulting in lightning fast load times and a significantly improved user experience. The CDN market is dominated by several key players, each offering unique strengths and features. Cloudflare, perhaps the most widely recognized, Cloudflare offers a comprehensive suite of services beyond just content delivery, including robust web application firewall, WEF, capabilities, extensive DDoS protection, and increasingly, edge compute functionalities, like Cloudflare Workers, that allow code to run directly at the edge. It's popular for both small developers and large enterprises. Akamai, one of the oldest and largest CDN providers, Akamai is known for its vast global network and is trusted by many large enterprises, particularly in sectors like media, banking, and government, where performance and security are paramount. Amazon CloudFront. As part of Amazon Web Services, CloudFront offers deep integration with other AWS services, like S3 for storage and EC2 for compute. It's a natural choice for organizations already heavily invested in the AWS ecosystem. Fastly, known for its real-time control and ultra-low latency, Fastly is favored by companies that require rapid content purging and dynamic content delivery, such as GitHub and TikTok. Each provider differentiates itself through its service-level agreements, SLAs, pricing models, the geographic distribution of its edge locations, and specialized features. The choice of CDN often depends on your specific performance requirements, budget, and existing cloud infrastructure. Understanding what can and should be cached in a CDN is crucial for optimizing performance. Static files. This is the bread and butter of CDN caching. Images, CSS style sheets, JavaScript files, font files, and pre-recorded videos are ideal candidates. They rarely change and are frequently accessed by many users. Dynamic content. While traditionally CDNs excelled at static content, modern CDNs, especially those offering edge compute capabilities, can now handle dynamic content. This might involve custom caching rules or executing small functions at the edge to personalize responses before serving them from the cache. However, this requires careful configuration to avoid serving stale or incorrect data. Personal/sensitive data. You must never cache personally identifiable information, PI, or highly sensitive data, like user bank balances, health records, or authentication tokens on a CDN. This is a critical security and privacy concern. Such data must always be fetched directly from your secure origin server. To control how your content is cached, you primarily use HTTP caching headers like cache control, which specifies directives like max age for expiry and etag, an identifier that helps determine if a cached version of a resource is still valid. Combining effective CDN caching with client-side browser caching delivers maximum speed by ensuring content is served from the fastest possible location. CDNs are integral to the daily operation of many of the world's most popular platforms. Netflix, a global streaming giant, famously doesn't rely solely on third-party CDNs. Instead, it built its own highly optimized CDN called Open Connect to efficiently deliver its massive video library to millions of subscribers worldwide, placing servers directly within ISPs' networks. Cloudflare empowers even small developers and startups to achieve global speeds for their websites and applications without the prohibitive cost and complexity of building out their own distributed infrastructure. E-commerce sites heavily utilize CDNs to cache vital assets like high-resolution product images, category pages, and even common search results. This ensures a snappy, responsive user experience, which is directly linked to higher conversion rates. Beyond speed, CDNs also enhance reliability. In the event of an outage or issue at your main origin server or a specific regional data center, a CDN can often provide failover capabilities, continuing to serve cached content or intelligently routing requests to an alternative healthy origin, ensuring uptime. Finally, CDNs contribute to better SEO, search engine optimization. Faster page load times, a direct benefit of CDNs, are a recognized factor by search engines, leading to higher rankings and improved visibility. To summarize our discussion on CDNs, CDNs are absolutely critical for achieving scalable, high-performance, and reliable delivery of web content in a globalized internet. Their core function is to cache content closer to users, dramatically reducing latency and improving load times. Leading providers like Cloudflare and Akamai handle billions of requests daily, forming the backbone of much of the internet's content delivery. As a system designer, you have significant control over what's cached by utilizing HTTP headers like cache control and configuring specific rules. Ultimately, CDNs are a must-know topic for anyone preparing for system design interviews and are an indispensable tool in the practical design of any high-performance, real-world application. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.